Hello, this is a demonstration of how to use the PhET refraction and reflection simulation to explore some of the patterns we've been looking at and help answer this question of what the world looks like from a fish's eye view and why. So I've opened this PhET reflection and refraction simulation, and we're just going to use the intro section of it right here. The rest of this we don't need right now. And so opening the intro, here we are. And I am going to move this light source right up here perpendicular to start with, because that's the easiest case, and turn it on. Hopefully at this point you are not surprised by the fact that the light ray goes straight through. And probably you're not surprised by the fact that if I change the angle, like so, I start to see some more interesting things happen. Right here at the interface, we see a reflected beam reflecting off the surface. If you have experienced water acting kind of as a mirror, you're familiar with that effect. So some of the light is reflected, but the rest is refracted, and you can see it's at a slightly different angle than it was going at. If I line this protractor up here, we can see the angle has changed from about 31 to about 22 or so. So it has turned. Put that back. We can actually kind of measure how much light there is. We can see, let me see, how's that work? Put this here, there we go. So 96% of the light goes through and the other 4 or so percent is reflected off. Okay, so we have those tools, and the patterns we can begin to observe, as we have noted in class, is as we turn this more and more, this turns more and more, we can note that this angle of the reflection is the same, but the angle of the refraction gets more and more away from that reflected angle. One of the things that happens is as I go far enough, there's only so far this incident angle can go. It can only go to 90. And so as I get to 90, there's a limit to where that light from outside can get to. It can only get to over here from this spot. Which means that if my eye were right here, and I were looking at that spot on the water, I couldn't see any light from outside the water at that spot. None of it could get to me. And so if I didn't see any light from outside at that spot, I must only be seeing things from inside the water, which means it must somehow be acting as a mirror the other way. We'll get to that, okay? So that's one of the things we see. One of the ways to try to see this then from the other perspective is let's switch it. Let's switch it so that the top is water. Right now this is boring because we see no changes at all happening. The light just goes straight. But if we make the bottom air now we can imagine what it's like for light coming up from the bottom of the water. Unfortunately, I can't turn the PhET upside down. So I can't have the water come from the light come from the bottom, but I can pretend like the bottom is the top. So now this is water, so this is the bottom of the lake, and this is the sky. And now imagine what water coming from the bottom does, light from the bottom does. It goes up, hits the surface of the water, some bounces off toward the bottom at an equal angle, and some refracts out toward the horizon. And as this angle gets bigger and bigger, sorry, I went too far, that angle also gets bigger and bigger. And since this angle is larger than that one, there's kind of a limit to what we can do here. When we get to about there, this light at 40 something degrees is coming out almost at 90 degrees, which means if I go a whole lot beyond that, it doesn't come out at all. So light hitting from here has to only bounce off. And so if my eye were over here looking at this spot, I would see the light from under the water. My recording is ending in 18 seconds, so we're going to stop right there, and hopefully that's helpful. How do I stop the recording? I can't find the stop the recording button.